These are the notes for a handout titled Solving Equations. So let's take a look at some of the problems. First one here asks us to solve an equation with variables and constants on both sides. So what I'm going to end up doing first is isolate the variable. So I'm going to go ahead and take this 3x and subtract it from both sides. Notice I'm putting the 3x underneath the 5x because those are the two terms I can combine. So what I've got left is a negative 4 equals 2x plus 12. So from this point, I'm going to go ahead and subtract the 12 from all sides because that's my constant, and I want to bring constants all to one side, variables to the opposite. So I add these two numbers because they're the same sign, and I just have one more step to do, and that's divide by 2. And that leaves me with negative 8 as the value of x. Next problem is a little bit more challenging because we have to collect some like terms on both sides of the equal sign first. So notice the signs there, they're opposite signs. So that tells me I'm going to end up subtracting those two numbers. So I end up with a negative 2, and then I'll bring down that positive 2x. On this side, I'll go ahead and combine that 2x and the 3x. Those add together because they're the same sign. That makes 5x minus 6. So from that point now it becomes a problem like we had just solved, where we're going to bring x's to one side. Notice I did opposite operations there. And I bring down that negative 2 equals 3x minus 6. So then I just have the one step of adding 6 to all sides. And notice they're opposite signs on the left-hand side here, opposite signs, so I subtract the two numbers. The one further from 0 determined the sign. And then all I have to do from this point is divide by the 3. And I have a improper fraction as the answer, and that's fine. It's reduced, so we'll just leave it like that, 4/3. Next problem is a little bit more challenging because I have that minus sign out in front of the parentheses there, so that tells me I have to distribute that negative sign. And so one number I could put between the minus sign and the parentheses is a 1. That's the number I'm going to distribute over that subtraction. I'm also going to distribute the 3 over that subtraction on the right-hand side. So what I've got left is an 18 minus 3 plus 2y. Make sure you have a positive 2y there, equals 3y minus 15. So now it becomes a problem like we had just done with the second one, where I've got to combine some like terms. I'm always looking at the signs in front of the term, not behind. So 18 minus 3 gives me 15. And then bring down that plus 2y equals 3y minus 15. So I go ahead and bring terms from one side to the other, so I'll subtract the 2y from both sides. And that leaves me with a 15 equals y minus 15. So then I just have one more step, and that's to add this 15 to both sides. Notice I'm bringing the constants to the left because the variables are on the right-hand side, so I'm left with 30 equals y, and there's my answer. Well, the next few problems deal with some fractions, so if you don't want the fractions, I recommend getting rid of them. So the way we do that is we multiply by a number that will cross-cancel both the 3 and the 2, and that would be 6. It's the least common multiple. And so we'll do some reducing there. 2 goes into 6 3 times, and I'm going to multiply these numbers, so that makes 3x. 3 goes into 6 2 times. Again, I'm going to multiply these numbers, and I end up with a 4x. And then 6 times 4 makes 24. So from that point, all I have to do now is subtract that 4x from all sides. Now, I'm not done yet because when I go ahead and subtract the 4 from 3, I end up with a negative x equals 24. That's the same thing as reading as the opposite of x is 24. So if I was to get rid of that negative sign, I'd multiply or divide by a negative, and that will cancel it out, leaving me with a negative 24 equals x. That makes sense. The opposite of x is 24. That means x would be negative 24. We'll do the same thing on this next problem. I'll go ahead and multiply by a number that will cross-cancel both the 4 and the 5, and that would be 20. So the key is to multiply every number by 20. That's why I like to write 20 next to each of the terms, so that it reminds me to multiply every number by 20. I also like doing that so I can cross-cancel and see what's left over. So 5 times by 1x makes 5x. 5 times 20 makes 100, so minus 100. 5 goes into 20 4 times, makes 12x. 6 times 20, well, I'll just do 6 times 2 is 12 and add the 0, so 120. Well, from this point, I'm just going to move terms around, so I'll go ahead and subtract that 5x from all sides. And I can also, at the same time, subtract the 120. Now, notice the signs are the same right here, so I'm going to end up adding those two constants together, and that gives me negative 220 equals 5x. And so when I go ahead and do the, let's see here, I have to subtract the 5. I had a 7 here, so I made an error. Let's go ahead and fix that real quick. So I subtracted the 5x from both sides, but I don't have a 5 on the right-hand side. So there, we'll fix it there. So subtracted 5x from both sides. Maybe I was thinking of the answer as I wrote that number down, because 12 minus 5 does give me 7. And so what I need to do now is divide. So I'm going to divide that 7 into negative 220. Well, 7 goes into 22 3 times, with 1 left over. 7 goes into 10 1 time, with 3 left over. So my answer would be x equals negative 31 3/7. So the next problem here, I'm going to go ahead and multiply this 2 over this addition. So what I've got left here is a negative sign. Do some multiplication. I've got 2 plus 6a. I'll bring down that plus 6 as well. And this all equals 5a. So I'll continue simplifying inside the parentheses, or brackets in this case. So I have negative 9a minus, and then I'll bring down that bracket, and I'll combine the 2 and the 6. So that makes 8, and then I'll bring down that plus sign, the 6a. This all equals 5a. So now I'll get rid of those brackets. What I'll do that is distribute this negative sign over that addition. So what it leaves me with is a negative 9a minus 8 minus 6a. So when we distribute a negative, just all the signs end up switching. Bringing down that equals and the 5a as well. So now I can combine some more here. So 9a, a negative 9a minus 6a. Look at the signs in front again, never behind. And combine those. Since they're the same sign, I add those two numbers together. It makes negative 15a minus 8 equals 5a. So what I need to do from there is bring all the a's to one side. So I'm going to go ahead and add that 15a to both sides. So when I do that, I'll bring the problem over here. Negative 8 equals 20a. So notice I brought down the negative 8. 5 and 15 made 20. So we got one more step. Divide by that 20 and reduce the fraction. So look for that common factor. So I see 4 goes into these two numbers, so that's what I'll divide by. And when I do that, I'm left with a negative 2 over 5 as the value of x. Well, one more problem here. It talks about Lola's age is. Is always tells me I've got an equal sign there. So Lola's age, don't know what that is, so I'll use an L for Lola's age. So L equals 14 more than 6 times John's age. Don't know John's age either, so let's use a J there. So 14 more means I'm adding 14 to something that's already there. So let's start with the 6J, so 6 times John's age, plus 14 years. And then it gives me another equation here. It says the sum of their ages, so the two people's ages, is means equals 35. So let's go ahead and write that down. L plus J, so Lola's age plus John's age, the sum of their ages is 35 years. Well, now what we're going to do is we're going to substitute. I'm going to take this expression right here, the 6J plus 14, we're going to put it in place of that L down below, that sum equation. So now I have 6J plus 14 plus J equals 35. So all I need to do from this point is collect some like terms. The 6J and the 1J add to make 7J. And then I have a plus 14. So I'll fix that J, make it look a little nicer there. So from this point, I can set that equal to 35. And Now I can subtract that 14 from both sides. So when I subtract 14 from 35, that leaves me with 21. So I'll rewrite it up here at 7j equals 21. So just one more step. Dividing by 7 gives me John's age. So j, which represents John's age, is 3 years. That's how old John is. Now what we need to do is find Lola's age. Well, I'm just going to substitute back in for that expression that represented Lola's age. 14 more than 6 times John's age. So Lola's age equals 6 times by 3 plus the 14. So we multiply first, and we get 18 and 14 add to make 32. So 32 years. That's what Lola's age is. John's age is 3. Well, those are the types of problems you'll see on tonight's homework. Good luck.